friction loss in a DC machine is proportional to. Okay, there are brush friction loss and also bearing friction loss. There is slight confusion between these two. Okay, brush friction loss, it takes place, that is directly proportional to n square, whereas bearing friction loss is only proportional to speed. Okay, now this is brush friction loss is directly proportional to speed square, so option D is correct answer.
In case of motor operation, the brushes are shifted in opposite to the direction of rotor rotation is. Okay. Then what happens to the flux and speed of the motor? See, when motor operation, the brushes are shifted in opposite direction of rotation. Suppose if motor is rotating in like this, the brushes are shifted opposite to the rotation of rotor. So what is this effect? This effect is nothing but an armature reaction effect will be there in motor. Okay, if you have armature reaction effect, there are two types of fluxes we have. One is demagnetizing effect, another one is magnetizing effect. Okay, now what is demagnetizing effect? Flux is weakened, so flux is distorted. What about cross magnetizing effect? In cross magnetizing effect, we have flux is distorted. So what will be the resultant flux here? There will be a demagnetizing effect and there will be a cross magnetizing effect. So what happens to the effective flux? Flux effective is reduced. So what happens to speed? Speed will increase. Now see the options here. Flux will increase. This is wrong option. Speed will decrease. This is wrong option. The only option which is correct one is flux will decrease. So option C is correct.
Generator, okay, if you have maximum current, then power factor will be lagging, leading, unity, or either A or B. In synchronous generator, if you see the curves here, like this it will be there. Okay, this is the maximum value of current, and this is also maximum value of current, and this zone is UPF zone. Okay, less than UPF zone you have leading power factor, whereas overexcited zone we have lagging power factor. So this point is comes under leading power factor zone, this point comes under lagging power factor zone. So maximum current is possible both in leading and lagging zone. So either A or B is correct answer. So option D is right. Magnetic field loss is less in case of, okay, if you see PMMC, moving iron, electromagnetic, electrodynamometer, watt meter instruments, okay, these are all having magnetic fields. Okay, whereas in electrostatic instruments we use capacitors. Okay, that means we have here only electric field. We don't have any magnetic field in electrostatic instruments. What does it mean? That stray magnetic field loss will be less in case of electrostatic instruments. So option C is correct answer. Control over the output voltage, the minimum firing angle maintained for following single phase converter with RL load is, okay, here the firing angle alpha should be greater than or equal to 5. When alpha less than 5, there is no control in the single phase AC controller. Okay, the minimum firing angle required to maintain is 5. What is 5 here? 5 is nothing but an load angle. Okay, what is load angle he has given here? Cos phi is equal to 0.8 power factor. So phi is equal to cos inverse of 0.8, which is equal to 37.87 degrees. So option C is correct answer. Circuit symbol is for, okay, if you see here, this type of symbol is represented for GT. We know that, let us see from options. We know that triac symbol as like this. Okay, this is terminal 1, terminal 2, and we have gate. This is for triac. Okay, and diac we don't have any. This is for triac. and this is for diag. Okay, similarly silicon control switch symbol is different. You have some 4 layers. Okay, you have anode and cathode. Silicon control switch is taken from inner P region as gate. Okay, this is not the symbol given here. Okay, the only option left is GTO. Option C is correct.
Question is, find the Laplace transform of a system that is sine 2t cos 2t. Here, if we multiply the input signal, that is signal by 2 and divide it by 2, sine 2t cos 2t, we can write it as sine 4t. So if we apply the Laplace transform to this signal, 1 by 2 4 divided by s square 16, which is nothing but 2 by s square plus 16. That is nothing but option C is correct. Is Fourier transform of the signal e power a mod t. So we can write e power minus a mod t as e power minus at u of t plus e power at u of minus t. Okay, so for this one a plus j omega, for this one this is going to be minus 1 by a minus j omega. So if we simplify this one, we will get 2a by a square plus omega square. Hence option C is correct. The Z transform of a signal a and u of n is, here a and u of n, if we apply a Z transform, we will get z by z minus a, which is nothing but 1 by 1 a z inverse, which is option C is correct. A system is described by the difference equation y of n equals to x of n minus x of n minus 3 plus x of n minus 5 minus x of n minus 7. The impulse response of the system is, here y of n is nothing but h of n convolved with x of n. So with the help of this property, h of n is nothing but delta of n minus delta of n minus 3 plus delta of n minus 5 minus delta of n minus 7. Hence option B is correct. Question is, the determinant of matrix A is 0, then the value of x is. Here the det of A is nothing but x square minus 1, which is 0 from the given data. So x square is x is under root 1, which is plus or minus 1. Hence option D is correct.